Silverado disc brakes, square body front suspension, going in my 67 C10. It's bolted in. Let's talk about it. Welcome back to Random Rod Shop, folks. Well, I'm continuing to try to put these Silverado disc brakes on the front of this 67 C10 we're working on. So yesterday, it was in the teens yesterday morning, so we still had lots of snow on the ground. But, you know, I decided I need to drag a pickup out of the pasture. And by the time I got done working on it, the sun had come out and I was working in mud. So I started the day in the freezing snow and ended the day in the chilly mud. So what I wanted was to cut this front end out from under I got an 80s C10 pickup down there that it was burnt, right? The whole front end, the cab, it was smoked. But I thought maybe it had a good front suspension under it. And it did. It took me pretty much all day yesterday to get the engine out. You know, never taken apart a burnt truck before. It's amazing what gets glued together. So, spent all day taking that thing apart, got it in here, and this morning, I've pretty much spent half day today just trying to get this thing jigged up on here, trying to get it, you know, trying to get it level. It's not perfect, but it's pretty close. So front to back, it's pretty good. Left to right, still just a little low on this side, but I think that'll be okay. Last time we were working on this, we put together sort of a hodgepodge of a lower control arm. Took the ball joint out of the Silverado, and it looks like this. I don't know if you guys have drilled these things out, but this was a bear. I'm not sure. I'm not sure if I had to do this for a living. I think I would make a jig for this control arm and put it on a stinking press so I could press these things out. Cut the tops off with an air hammer and just press them. That means you got to take it off, but I think it's worth it. These are bare. 1/2-inch rivets, by the way. I think they're probably metric. I don't know. Big rivets, and they're 3/4 of an inch thick. That was a rabbit hole. Anyway, so in the last video, we got this mounted in a C10 control arm. Now, mounted is a strong word, but it is in there. And, you know, we did our best to try to get it positioned at the right angle, such that the distance between the ball joint and the pivot is the same as the factory C10. And I think, after it's all in there, I think we did a pretty good job. This is the stock C10. So this front end is a 82, 83, something like that. These are the upper control arms that swapped on my kid's 85 C10. So stock C10, upper control arms. This is the Silverado spindle, and pretty much all I needed to do to get that thing bolted in was I needed to open up this ball joint hole and open up the tie rod hole. Now, so let me show you why this is interesting. So the biggest problem on the ball joint was that this thread is smaller than the end of the ball joint. On the GM, that pretty much just kind of tapers out. The threads are pretty much the same diameter as the end of that ball joint. Basically, you got to drill a hole through the tapered hole so that you can get your stud through. That's the first step. And then I picked up a 10-degree reamer. That's the cat's meow. I had a 7.5, or a 7. I had a 7, and I forget. I'm maybe getting confused between the vintage Stratocaster necks at 7.5 and ball joints at 7. I don't know. Okay, So that really was, pretty much all it was. Just open up the holes, open up the hole. That really didn't take much on that one. You're not really opening up the hole. All you're doing is opening the bottom up so you can get the ball joint through it. This one you actually have to open the hole up. So, but again, I just took that 10-degree reamer and went all the way through it until it all mashed together, and it seems to be happy. So at this point, it's all bolted together, right? That's the factory tie rods off of the C10 and steering box. Basically, it's the whole front end. You can see where I knotted off underneath there, but anyway, that's the whole front end. Open up the holes to get the upper ball joint of the C10 and the C10 tie rods to go into the Silverado spindle, and then working on this. The reason I wanted to get it mocked up was once I know exactly what that lower control arm needs to do, I'm going to build a jig that holds that ball joint and holds the pivot points in the back, and we'll make a control arm. Okay, so I actually have this thing. I've got the shims in it. I don't have enough shims to get it exactly right, but let me show you what I got here. Before I do that, I wanted to show you the shim pack. So there is 5, and then a small one, and then there's 3. Let me go to the other side. So on this side, I've got 5 and a small one, and I got 3. Let me show you what the caster and camber looks like. So let me show you what we got. Here's the Silverado side. Got about 4/10 of a degree of camber, and it's pointing the top of the tire is closer to the vehicle. And on the caster, we got 4.9. The key is, I'm happy with those numbers, but the key is there's still room on the shim pack to make those, to even do some more adjustment. Right? You've still got, you can, if you decide you want some more caster, there's room here to grab some more. Let's go look at what the let's go look at the C10. You know, while I was messing with this, it reminded me of the issues I had with trying to measure the 71. We'll go back to that Silverado after we get done with this, and I'll give you another reason why that's a really good deal. So let's look at the camber. Well, I've got about 0. I need to just get some more shims, and we can get this thing dialed in. But we're only looking for, 0.2 or so, 0.2, 0.5, somewhere in there. Let's, I don't know if I can get the camera in here. This is about the only flat spot, and this is what I ended up doing on my 71. This is about the only flat spot that seems to be perpendicular, if you will, to the system, if you will. So I got about 5.1. So the caster is about 5.1. And again, the caster, the line's going like this. Pretty much like the other side, it's close to 5. Before I leave that, you notice how I measured the caster and camber on this side? That's a machine surface right there. That will make it pretty stinking easy to set your suspension up. That made me smile. All right, I'm gonna grab the camera. Let's go around. I've got the tie rods hooked up and everything, and this thing is pointed as straight as I can make it. Right? I basically put a level on both sides and measured to the best of my ability. It's pointed forward. It looks like, the toe end may be just a little off on it, but at this point I think I think it's got somewhere a little more than 1/8 of an inch toe in. But let me give you some numbers of what I got going on here. So let's look at the tie rods. All right, so this is not going to be an exact science, but it'll give us some idea of the differences. So, well, the original tie rod is pointing down, right? Pointing down from there to there, about the 1.7 degrees. The Silverado spindle side is pointing down about 5.6, give or take 5.7. Oh, there's an 8. So it's creeping up on 6 degrees. So normally changing the tie rods can cause some bump steer issues, but I've turned this around. I'm not sure there's a big issue going on here. I'm going to do some more playing just to check, but in the end, I'm not sure that's a big deal. So far so good. The other thing, and I think I talked about it when we were working on it the first time, but it would appear that the spindles, the Silverado spindles, will actually lower the pickup also. It's not the 2 inches that I think I said when we were working on it. It's more like an inch and a quarter, but it is a lowering spindle. The other thing that, and I mean, if you do the measurements, it makes sense, but I didn't measure it the first time. So the height, if you will, from where the wheel mounts to, back here, this is an inch more compact than the C10. So this stack up here, give or takes about 5 inches. On that side, it's 4 inches. So when it's all said and done, I said give or take. From the wheel mounting surface to the mounting point for the lower control arm, when you put the Silverado spindle on it, that distance is about 3/4 of an inch less than the stock C10. So overall, wheel mounting surface to wheel mounting surface is going to be about 1.5 inches less with the Silverado spindles versus the C10. And it should be about 1.25 inches lower. That all seems okay to me. The narrowed track width, you could put more dish wheels on, and with the higher kingpin angle, I think that all works together. Probably have to draw it up on paper to be sure, but I think with the steeper, remember we said that the kingpin inclination angle on the Silverado is about 11 degrees, and this was 7.5. So that should actually help us out if we put some wide tires on this thing. And we got to put fat tires, right? The other good thing is the stops for the steering isn't going to be as problematic as I thought. Now, keep in mind, the steering arm was 6.5 inches on the C10, right? So even if the steering box moves the same amount, the sweep on that 6.5 inch arm is going to be a little bit more than it was on the 6 inch. So this will have a slightly shorter turning radius, but given all the benefits, I'm willing to live with that. I'm going to turn the steering box here. Let me get these down because I'll probably knock them down. All right. So now that's the stop on the box. And relative to what I got welded together here, I'm not hitting the lower control arm. So we got room to build a stop in there. Let me see if I can show you. I know it's hard to see there, but I've got a gap right there. So we got enough room to put a stop there. So that one is just hitting right here on this corner, which isn't a big deal. And that was the end of the stop. or the end of the steering box. I pulled the tie rod off and checked it, and before it really bangs into that control arm, the box stops. So we're getting a full swing on the box. We're just going to have just a slightly smaller turning radius. The other thing I wanted to show you is because the ball joints on the Silverado spindle both come from the top down, and the ones on the Silverado come from the outside in, right? So the lower control arm points up and the upper control arm points down. I didn't truly appreciate what that was going to do till I got it bolted together here. So the artifact of that ball joint going on top rather than on the bottom. Now keep in mind, you know, mounting boss, this was about an inch longer than the C10, but the stack up of that ball joint is more than the inch that's different. What that does is it positions the lower control arm up, right? Because you've still got, you know, if I look at the bump stop here, at this point I don't have as much bump stop room on this side than I've got right here on the stock side. But the distance from the control arm to the cross member is about 1.25 inches shorter, because I've got the other side set at 6 1/4, because that's what my kids' pickup sets. That's the way it sets naturally, right? It's just a stock C10, and it's setting at 6 1/4. This one's setting at 5, so it's about 1.25 inches difference that I believe is all wrapped up in swapping that ball joint around. So what do I think at this point? Well, my takeaway is, going this route, I get 6 lugs that match the rear end we put in. I get a 12-inch disc brake rotor versus the 11.5-inch rotor. I should get a little better geometry because of the increased kingpin angle, right, when I put fat tires on it. And speaking of fat tires, it's just a little bit narrower, so you have less issue if you put fat tires on it. Adapting the C10 ball joint or tie rod end and ball joint is actually pretty straightforward. So the only difficulty in this whole thing is the lower control arm, and relatively speaking, in terms of lower control arms, I think this one's going to be pretty straightforward. So I'm going to continue on down this path. The next step, now that I see this thing, I'm pretty confident this thing's going to work. We'll start building the jig so we can figure out how we're going to do the lower control arm. Before I forget, keep in mind that the lower control arm in many ways has kind of some of the same problems as the trailing arms, right? If you don't give the trailing arm a twist, then you probably shouldn't use polyurethane bushings. Same thing with the lower control arms. If you decide you wanted to use the stock bushings, right, keep in mind that those things do not rotate. And so a normal tubular control arm is going to be fighting, right? It's going to be fighting that bushing. So I don't know that how comfortable I am with the stock bushings in a tubular control arm, right? Because the bushing just twists, right? There's no relative movement between any of the components in that bushing. It's just the rubber just stretches. Especially in terms of a lower control arm. With a tubular one, it needs to be polyurethane so that you get some relative spin. So the next step, I think I'm going to build a jig so we can modify a stock lower control arm to use that Silverado ball joint. I'm not saying we're not going to end up making a tubular control arm, but right now we're going to just modify a stock one and see how much trouble we get into. All right, well, it's been a long weekend. I rolled in the snow yesterday morning, rolled in the mud yesterday afternoon, and kind of did a lot of grunting to get this thing up here. So I've run out of time. I hope you found this interesting. if I missed something that I should have pointed out, or if you got questions about anything specific, this thing's going to be on the table for the next week. So if you want me to measure something, let me know. All right. Well, if you subscribed, I appreciate it. If you haven't, hit the subscribe, leave a comment, leave a like, and until next time, I'm Random at Random Rod Shop, and I'm out of here.